Thank you, Dr. Curry, for the enriching address. I would now like to invite on stage Mr. Sanjeev Chauhan, Vice President, Solution Engineering at Oracle. Sir, the stage is all yours.
Thank you so much. Right, so we move forward. Thank you so much for giving us this opportunity to connect with such a esteemed audience here. Right, we have spoken enough about, let's say, the complexity today, that what is the outcome that everybody is looking at. And you clearly saw that the real interest for whether it is G2G or B2C, G2C use cases isn't on the outcome, right? And this is the outcome, let's say, most of us are wanting to drive. And it depends whether the outcome is to be driven for the government or the outcome is to be driven for, let's say, individual citizen, right? And based on the topic that was given to us for having a larger discussion with the group here, essentially we focus on three areas: data management, because tons and tons of data that is currently being generated, how do we manage it well, and use all sort of things that we've spoken about: machine learning, artificial intelligence, to ensure we can make sense out of this, all the data that we generated. And second is, what exactly is the IT infrastructure in the backend, right? We need to standardize on some part of this information, because most of the information need to be exchanged with other parties, right? Agency generate the data, it should be consumed by another seamlessly. So what exactly is that platform? And third is obviously around the skilling part. A lot of us come with either skills around IT or skills around geospatial, but the marriage of these two is what is, let's say, going to drive the end outcome. And based on this, so today look at, let's say, the kind of data that we have. It is not just longitude, latitude. And in the beginning, the mention of, let's say, extracting Z value. And if you know a project called Digital Address Code, where you can have a address somewhere, at the 10th floor of a building, right? And then we need to extract Z value. So at least that we can attribute that particular location for your physical address. And it is sort of, let's say, unique ID for your residential address. And the Department of Post is working on that project, right? So definitely it is not just, rows and column, horizontal scale. It is essentially the Z value, and a lot more feature need to be extracted. You need a data source which can take all sort of this information together and do a lot of backend processing. In addition to that, obviously, there's expectation of advanced geospatial models like spatial network for roads, transportation. You need to have topology of mappings, and all of this, some of you are already doing it, and many of these organizations, this is the aspiration, right? And then add to that raster, 3D, point clouds, and LiDAR support that you would require in the existing databases. And what we do essentially need for all that is ensure all of this is backend supported, right? If you look at any of you come from, let's say, the database background or data store background, 20 years ago, we did not have a function called primary key. We would build a 2x2 table to simulate a primary key inside the database. Today, all this functionality is available out of box from the databases. So these are the functionality that we require, which essentially is something like, finding out distance between two locations, figuring out what is the proximity that two individuals had with each other, right? So we could determine contact, and this is the API that we built during the COVID time, which is available out of box from the database, is that we can find out proximity between two individuals. If and this has, let's say, utilization in a lot of other places, not just COVID, but let's say also for security agencies, where they have mobile location of two individuals. They want to figure out whether they were in close proximity to each other for, let's say, greater than 30 seconds, and then they can figure out these people have, let's say, met each other, and then they can further progress and make a, let's say, complete model out of the same, right? So these are the functionality that we're looking at. So today, all of this is being built over and above the data source that we have. So is there a way that we can get this functionality out of box, which is the work Oracle is doing? They built 300 plus functionalities. You just get all the data in the data store, right? And all these functions are available out of box for you, and you can just start building your application. You can use the low code, no code platform, and which is what, let's say, the gap that we're trying to address in the projects like Swamitva, where you have the ability to get all the data, right? You store all the data in some shape and size, but to then further build applications on the same, you would need, let's say, some sort of programming abilities. And folks who come from geospatial skills are not, that great at, let's say, writing codes, etc., and doing complex calculations. So is there a way that a platform can provide them out of box, functionality of doing this complex calculation, doing machine learning out of box, building applications which can be done just by drag and drop like we used to do 20 years ago. So it is that simplification that we're trying to address with the databases, right? And you can do this, all sort of business rules. You can do it inside a physical building where based on your swipe in, swipe out of the card, right, you can do the proximate tracking between two individuals, right? So we're taking not just capturing of data, we're storing the data and then doing a lot of this backend functionality which you would otherwise build on your own, right? And improve those algorithms. All these algorithms, the 300 plus of those, are available out of box from the database that can store this information, right? So for developers, what we have is we have essentially, so you have all the data, you want to start building applications out of box, right? And you would want to build applications on the public cloud, on-prem, on your device, etc., right? So there are sort of possibilities that you have. You can fairly easy to use. So whatever technique that you're today using, if it is the scale which is most, use a standard query language to get data from the databases. So whatever ANSI compliant SQL statement that you've been running on existing databases, you can bring them here and you can start querying the data. The other popular mechanism today is JSON, right? Which is where you, let's say, have the complete payload of data, use exchange information based on JSON. So all of it is JSON compliant. In terms of performance and let's say availability, right? What additionally you would want to do in this environment is obviously you would want it to auto take care of itself, right? And which is what, let's say, the buzzword and the conversation around cloud is that it should be self-managed, self-expanding, self-performance tuning, etc. So that's something that we essentially build as DNA inside the database. So what we've been doing with databases is ensure, let's say, all of this can be auto-patched, right? So you have a platform today, you would take some downtime to ensure the patchings and updates, etc. is taken care. But when it comes to Oracle database, it has the ability to auto patch itself, right? So you don't have to patch it anymore. You don't have to upgrade it anymore. All of this is taken care of by the database itself. The another important aspect the DBAs tend to do, because you have, let's say, tons of data. And when I say tons of data, it is petabytes of data that you carry when it is geospatial information about, let's say, just a state alone. So how do you, let's say, performance tune this database? So one important task most of the DBAs do in the databases is create indexes, right? Which is where they spend 50% of their time performance tuning the underlying platforms. Now, what we have the ability that database learn on its own and create indexes on its own, right? So it has the algorithm built in where it checks the existing indexes and figure out whether the new index will give you better performance for your queries, because it has been doing that in the background. And it will drop the old indexes, create new indexes for you. So all of this is absolutely autonomous in nature and doesn't require any user interference whatsoever. Then coming to, let's say, visualization, which is what, let's say, used to be, let's say, important ask from a customer. We have had a geospatial feature inside the Oracle database since 1995. A lot of Indian customers use this geospatial feature. A lot of global customers have been using it as part of their application. A lot of mobile banking application use geospatial as the backend Oracle database feature. But now we have the spatial visualization where you can look at the visualization out of box. All these visualization tablets have been automatically created. It'll tell you the best visualization possible for the data set that you provide. So you throw all the data in, right, based on what kind of data it is, right? It will show you the best possible visualization that is possible out of box from this application, right? These are some of the autonomous features which I mentioned in terms of it can auto-tune, auto-patch, auto-secure, auto-encrypt all your data, and everything is encrypted by default, right? So there's no possibility that somebody can take your data, restore the data some other place, and then play around with the data. These are things that are available to you, right? And I'm being conscious of the time. You can run all these technology in your data center, as most of the customers are today doing, right? You can run it in your laptop, the device, wherever you want it to be. You can run it out of Oracle data center. You have 3 data centers in the country, Delhi, Hyderabad, and Mumbai. A lot of the banking customers run their application out of these places. It is MATI certified. We have what we call the autonomous geospatial service, right? You can run all of these services and you manage it as just the database and don't have to bother about, let's say, how the backend patching performance tuning is done. And in case, let's say, you want this cloud to come to your data center and you want to run it in the OPEX mechanism, so that option is available. We'll give part of our cloud, send it to your data center, and 4 years later, we do technology refresh on our own without any cost to you, right? This is what Oracle does, in case some of you are not aware what exactly Oracle into. Oracle does everything end to end. We do build infrastructure. We acquired a company called Sun Microsystems, so we have the pedigree of ensuring high performance systems are built grounds up, and we have the pedigree for last 4+ decade. We have the databases application tier, application development platform, and also the vertical business applications. This is what we do, right? So the summary of our discussion is what exactly we are doing here for geospatial. So we have what we call always free tier, right? This is a cloud offering from Oracle. Any of the developers who, let's say, and even for a startup who want to start building application. So this is available to everybody and anybody for free, right? You can just go and start building application. These are the, let's say, compute options are available to OCPU, lifetime free. You can run autonomous services out of box, and whatever I mentioned about autonomous, which is patching, securing, etc., all of it is available as free to for people, developers to start developing application. What are we doing in terms of toolkit? We also found out, let's say, a lot of people have concern that the work to be done through a lot of open source software. We need visualization software. We need certain APIs. We need certain compilers, etc. Right? Some features, some tools to extract these features. So build all of these as a single toolkit together with Oracle, non-Oracle product. And it is available as object storage image. So whosoever is interested, my email address will be there at the end of the presentation. You can ask us, we'll give you the kit object store. You can take the object store image, restore it on the free tier, and you're ready to go, right? We don't have to spend any money, of, let's say, doing that work yourself, right? And the third and the last thing is training and enablement. We've ran multiple sessions, couple of days workshops, free for all the customers who would want to, let's say, start building applications in Oracle Cloud using all these open source tools, right? More than happy and willing to extend the same to you, right? Plus all these certifications, Oracle certifications are free to anybody across the globe, right? So if you're interested, I'll share more information, right? With that, this is my contact detail in case you want to reach out. More than happy and willing to address any query. Thank you.